All right, good morning, everybody. This is, we're in Chapter 3, Acceleration. Today I'm going to show you how to calculate position with average acceleration problems. Before I get started, though, I want to remind you that today is Thursday, the, oh geez, I forgot the date, 22nd of October, and tomorrow at 11:59 p.m. your technical reading is due. I have to have it by that time. If it's a minute late, I'm not grading it. It's a 0. You're not off to a good start in the second 9 weeks. So make sure that you are meeting that deadline. It's so important. There wasn't a weekly exam response this week because of the technical reading, but next week I will be assigning weekly exam response number 7. In fact, it's on Google Classroom as of yesterday, so it is out there for you. Okay, so today I'm looking at position with average acceleration. Some of you may have already looked through those notes. Hopefully those notes helped you. If not, hopefully this will be helpful to you. And as always, if you have questions, email me whenever. I'm not going to answer your email at 3 o'clock in the morning. However, I will reply back soon after I arrive here at school, so typically before 7 a.m. Okay, so position with average acceleration. The question is being answered is how far does the car move during the time it is either accelerating or decelerating. The formula here is kind of a long one, but it's not all that bad. X sub f equals x sub I, so x subscript f equals x subscript I, plus v sub I times t sub f plus 1/2 times a with a line on it times t sub f squared. You got all that? If not, there it is. Again, it's also in those notes that I typed up and shared with you in Google Classroom. So just to define the variables. Now remember, when I ask you to define variables, what I mean is, like I have here, x sub f, just write x sub f equals final distance. That's all you need to do. You don't need to write out like a definition of the term final distance. Just write this out and you're good. Initial distance, all right, x sub I, it's always going to be 0. For our intents and purposes, the initial distance will always be 0. Then we have initial speed, we have final time, we have average acceleration. One of the mistakes that is made with this formula is a lot of times students do not square the time out here. And if you don't square the time, that's really going to throw your answer off. So be sure you square this time. Now, what we have here, you'll be given a problem like this. And basically, if you read those guided notes, this is that problem that I'm just going to go ahead and solve for you as part of this video. It's typed out a lot neater in the notes than it is written out here on the dry erase board. So what we have here is a car is traveling at its initial velocity is 28 meters per second, and it slows down at a constant rate to a final velocity of 11 meters per second over a period of 6 seconds. We want to know how far does the car move during this time. The whole idea of this formula is for us to take a look at while you're either accelerating or decelerating, you are traveling a certain distance. What we're trying to find out here with this formula is how far did you travel while you were either increasing your velocity or decreasing your velocity. So you're provided with 3 numbers. You know the initial velocity, you know the final velocity, and you know the time. With those 3 pieces of information, if you think back to earlier this chapter, like last week we talked about linear acceleration. What we can do is we can take the numbers that we have here and apply them to the linear acceleration formula. Hopefully that rings a bell for some of you, if not all of you. So then you just plug in the numbers here. Remember, it's always final velocity minus initial velocity. So we're going to take, the final velocity is 11, the initial velocity is 28, and the time is 6 seconds. All right, so you know you're slowing down. You were traveling 28 meters per second. You dropped your speed down to 11, or your velocity down to 11 meters per second, and it took 6 seconds for that to happen. So you go ahead and solve that. And so this is negative 17 over 6. And that's going to equal, when you divide this out, you get a negative 2.83 meters per second squared. Now, what I've seen in the past with some students is they get this answer and they say, hey, I'm done. You're not. This number here represents the linear acceleration. I'm not asking what's the linear acceleration here. I'm asking how far does the car move during this time where it was slowing down from 28 meters per second to 11 meters per second. So once you get this point to this point, you still have to apply this formula here. All right, it's the same formula, of course, I showed you a couple minutes ago. So plugging in those numbers, it looks something like this. X sub f is what we're solving for, the final distance. The initial distance is always 0. Put it in the equation anyway, I want to see it, but just know that it's always 0. Plus, the initial velocity is 28. The time is 6 seconds. All right, so here's v sub I. So we write these down here just to help out. All right, then we're going to add 1/2, then the acceleration, the average acceleration, a with a line on it, that's what this is, times negative 2.83. And then we're going to square the time. The time is 6 seconds, so 6 squared is 36. Now, a lot of times what I like to do is just go ahead and solve everything to the left of the plus sign first, and then everything to the right of the plus sign. That works for me. Some of you can just say, oh yeah, just type all this in just like you see it, and you still get the same answer. Whatever works for you is fine. I'm just sharing with you how I typically approach this. Okay, so I'm going to go ahead and do 28 times 6, and that number is 168. Then we're going to add to that, we're going to multiply these three numbers together. Notice we have a negative number because we are slowing down, so you have negative acceleration. 1/2 times negative 2.83 times 6 squared. When you solve that, you get a negative 50.94. All right, then we go ahead and add these two numbers, and when we do that, we come up with 117.06 meters. All right, now, one of the questions that you will be asked on the test, before the test and so forth is, I'll say something like, take a look at your answer to the previous question. Okay, so we're basically going to analyze this answer here, 117.06 meters. And I'm going to ask you, what does this mean? What does this mean? I want you to try to explain it to someone who does not understand physics. So what you're saying is, okay, during the time that I was slowing down, I was reducing my velocity from 28 meters per second to 11 meters per second over a time of 6 seconds, I traveled 117.06 meters. All right, so again, during the time that I was reducing my velocity from 28 meters per second down to 11 meters per second, it took me 6 seconds to do so, and while I was reducing my velocity, I still traveled 117.06 meters. Okay, now, notice that in this particular case, we had negative acceleration, again, because we were slowing down. You still end up with a positive number, right? Because even though you're slowing down, you're reducing your velocity, you're still traveling however far, whatever that distance is. So just make sure that you're aware of that. Sometimes you have to have a negative acceleration, other times you do not. Now, what I'll do here is I will show you example number 2 from the notes. In fact, the only thing I did was I switched the initial velocity and the final velocity. All right. So what I'm going to do to distinguish, this is example 1. I'm just going to flip the numbers around in example 2 and write it in green so that you can tell that there is a difference. So the initial velocity is 11, and the final velocity, oops, there it is 28. All right, so we'll switch this around as well. And again, this is just the new example. So we're going to do 28 minus 11. That's going to be positive 17. And this is going to be 2.83. All right, now what I'm going to do is erase this. That way I have some room. All right, so x of f equals, again, the initial distance is 0, plus the initial velocity is 11. We're going to multiply that by 6. We're going to add to that 1/2 times 2.83 times 6 squared, which, of course, is 36. All right? Now, let's see. Here we go. So we know 11 times 6 is 66, plus, so you go 0.5 times 2.83 times 36, and you get 50.94. So you end up getting 116.94, which is pretty similar to what we had before. But the idea is now, instead of slowing down, you're increasing your speed. And why you did that, why you increased your speed from 11 up to 28 meters per second, you got 116.94 meters. Okay. So there's 2 examples there showing you how how you solve this, what we call position with average acceleration. And again, all we're looking at, we're answering here, the question is, how far does the car move during the process of either accelerating or decelerating? In all cases, we're going to solve for the final distance. I'm not going to give you final distance and have you solve for something in here and make the algebra crazier than what this formula already might appear to be to some of you. But we'll solve for final distance every time. And just remember, it's always a 2-step process. Step number 1, figure out linear acceleration. If you don't figure that out, then you're not going to be able to solve for x of f. And another key thing to remember is when you are working with these numbers, working with these types of problems, once you figure out linear acceleration, you're not done. So don't think that you are. All right, because how far does the car move during this time? 2.83 meters per second squared. That doesn't make any sense. You're answering a distance question with an acceleration answer. All right, that's like saying, what's the temperature outside? And you say, oh, the temperature outside is 53 apples. That makes no sense. All right, so just make sure that you are, once you figure out the acceleration, take it a step further and plug it into this formula here and figure out what the position is with the average acceleration. And again, if you have any questions, please let me know. Just email me. If you need me to come and work with you one-on-one or in small group, I am more than happy to do that for you.